Right, ladies and gents, let us get to it. This is a problem I promise to do over as soon as I get some time for you. So, now I do have some free time and I'll go over this problem. So, it says here in the diagram below, AB is a chord of a circle with center O. M is the midpoint of AB. Prove the theorem that states that OM is perpendicular to AB. So as soon as you see the words center and chord, in your mind you must always think, okay, the theorem that states that a line drawn from the center perpendicular to the chord bisects the chord. All right, before we get on to the actual proof, let me acknowledge the document. This question was pulled from a vet's tutoring program, 2019. Okay, this is page 66 of that particular document. So, for me to start with this proof, I'll start with a construction. So, I'll say construct O A and O B because I want to have triangles that I will later prove to be congruent. And this is very imperative for this particular proof. In this case, then one can say OA is OB. And the reason for that is it's a radii. That's because OA is a radius and OB is a radius as well. And one can also state that AM is BM. And the reason for this, you can either write this whole statement, M is midpoint of AB, or you can just say given for this particular problem because they gave it to you right there. If they did not, um, then you would have to just write the statement for you. Okay. Then you can say OM is a common side. You can see that this side is shared by these two triangles. I know most people like to say OM equals to OM, then they write common side. No problem with that. So I'll do that. Let's follow the crowd. Right. As a result, we can safely say that the triangle AOM is actually congruent to the triangle BOM. Note I'm trying to follow the vertices that are corresponding A with B, O with O, M with M. And the reason to this is side, side, side congruency. Now, one would say, but how would a 90-degree come out of a side, side, side congruency? You now need to remember very well that because O is the center and OM, which is a line drawn from the center, and it bisects the chord AB, one can then state that from the converse of the theorem, we can safely state that angle AMO, which is this angle here, is the same as angle BMO, which is that angle there, and they are both equals to 90 degrees. And you writing that whole theorem converse would not just be a waste of time and space. You can just say RHS, but we know that it comes from the converse of the theorem that states that a line drawn from the center perpendicular to the chord bisects the chord, or the perpendicular bisector of the chord passes through the center. In this case, it's a converse that states that a line drawn from the center that bisects the chord is perpendicular to the chord. Therefore, you can be happy and conclude OM is indeed perpendicular to AB. Voila. Okay, hope you enjoyed that.